Hi, everyone. Welcome to Structr 6.0. This session is going to be led by Axel Morgner. Axel, I am going to hand it over to you.
No, sorry. Now you can see me. Okay, sorry again. So, did you hear me? But you hadn't the picture, right? Okay, I would just start from the beginning. So, hi and welcome to my session about AI-enabled low-code development with Structr. For those who don't know Structr, it's a platform for low-code development based on the Neo4j graph database. So let me switch to my presentation. So I hope you can see it now. So Structr is a pretty mature product or system based on the Neo4j platform, and we've been around in the community since the beginning.
Sorry, Axel, we cannot see your slides.
All right. Okay. I switched to screen sharing, but
yeah, maybe.
Yes, here it is. All right. Now you can see it.
Now we can see. Yeah.
Okay.
Perfect.
Sorry, folks. Sorry, folks. Okay. So Structr is a low-code platform based on the Neo4j platform, and we are in the community since the beginning. And what's new in Structr 6.0, the upcoming release, which is about to be released. So we're just counting the days. Are the most important new features are the connectivity or the integration with AI tools. But let me give you an overview of what Structr is and what you can expect from it. And I have also prepared a short live demo if we get to it, if I have enough time. So as I said, it's a low-code platform for Neo4j. So it's basically a set of low-code tools, user interfaces that connect to our Structr backend, which is what we developed over the past 15 years, which also connects to the Neo4j graph platform or graph database. So you can think of Structr as a kind of workbench for your Neo4j applications. The company behind Structr is I would call it a very old startup, kind of. We're in the market almost 15 years now. It has been founded in 2011 by my brother and me. We are headquartered in Frankfurt am Main in Germany. We have a couple of international, but mostly German customers in the German-speaking countries. The company is still, and by purpose, entirely owned by team and friends, and we are profitable, and we are happy to do what we like to do, and this is making a good software and doing funny projects. So you see, we have a couple of smaller and also larger customers, and we are not focused on any special use case or industry. If you are interested in what we are doing with our software or what our customers do with our software, then please check out our customer stories on our website, structr.com. But as Notes is typically a more technical oriented conference, I will skip the marketing for most parts. The interesting question is if you have already learned about graphs and Neo4j and you're asking yourselves, why do I need an additional platform? So Structr is everything you need to build real-world applications without having heavy coding. So you can think of Structr as a kind of point-and-click interface, which supports you in doing your first steps. When you're using Neo4j for building out a database model, you can also create user interfaces, nice-looking web applications, and everything is comprised in one software stack. So Structr typically is all you need. You can install it just by starting up a Docker instance or downloading one file extractor and then just start the application. So typically you save a lot of time, and that also means you save a lot of money when building real-world applications. And in the beginning, you saw on the first slide, our claim is that we are optimizing for complex applications. And I mean, it's all about complexity when you are dealing with graphs, or when you're dealing with complexity, it's all about using graphs because you can just handle complexity a lot better. So what's new in Structr 6? There are a couple of features in the software where we'll go through quickly. One very important thing to developers or to anyone who is interested in data modeling, Structr supports multiple type inheritance. That's very important. I would give you an example, and maybe we also can do it in the live demo to see what it means. But it really helps you to keep your complexity in your data model low, and this is all what also low coding is about. Keeping a good abstraction of what you want to do, what you want to achieve with your software application, and so multiple type inheritance comes in handy. Also, we have created a new kind of file system abstraction. So Structr has a file system where you can store files and folders, images, media assets, whatever you like. And the hierarchy and the metadata are stored in a Neo4j database. But the binary data has to go somewhere. And typically the binary data of files or images are stored on the local server. But that, of course, when you want to scale out, that brings some problems with it. And so we created an interface to a couple of, or a generic interface where you can plug in a couple of file system connectors, you can call it. So for example, you can store your data still on the local file system, but also on an S3 bucket on AWS or in the Google Cloud or Microsoft or wherever you want. So that gives you the endless possibilities. Also to use different binary file storage providers for different purposes. For example, if you want to have a long-term storage, you push your files to Amazon Glacier. If you want to, if your live data or data you want to use or access very often, you store on the local SSD for better performance. And also interesting for developers is the modular scripting. You can see here on the slide in the middle that we are using the GraalVM, the JVM Java Virtual Machine from Oracle, which allows to use different scripting languages. And we have made the scripting modular, so you can write code and import it as a module in another script context, which is also very convenient. So on the infrastructure side, we have decided to push the open source nature of Structr. So Structr was always open source, but we have kind of hidden that fact a little bit in the past, but we are now going back to full open source, and we're building out a community. So Structr is open in any direction. Not only open source, but also has open APIs and uses open standards wherever you want. We're using the latest architecture. So Neo4j, we support all Neo4j versions up to the latest version snapshot. Also AuraDB, latest version of the Jetty Servlet engine that gives you nice performance enhancements. And I think the most important thing is that we enabled our architecture to become a part of, or accessible by LLM or AI tools. And I will show you what that means in a second. Yeah, already mentioned, Structr is not a black box. So everything you do in Structr, you can access through an API. And in combination with the AI connectivity, you can imagine what that means. So you can even look at the progress of an AI creating your software application while it's doing it. We will show that live or see it live, hopefully, if it works. So you can always interact. So Structr is completely open. You can access any data you created. And also the components of the application are stored in the graph. So it's open to you as a developer to just look at it, and it's easier to debug and easier to understand what's happening in the back end or on the backstage of the system. And also, as I mentioned already, we support most of the open industry standards and protocols, because we also just believe in open source and open access. I think that's having open systems just makes the software world a better place. And second most, or maybe the most important feature is, you can see it here in detail a little more, that we built an MCP server, Model Context Protocol server, that allows you to interact, or that allows LLM systems to interact with Structr, the Structr backend. And that just means that everything you can do as a developer with Structr is now also possible to just hand over to an AI system and just talk to the LLM or to the AI agent. And this AI agent knows all the specifics, how to use an API, how to use Structr. We have kind of taught the MCP server to understand and how to work with Structr through the APIs. So you don't, as a developer, you don't have to know everything, and all the little details you have to look up in the documentation are now kind of automatically or kind of hidden away from you. As Structr is open, you can still, of course, access everything and look at the system while it's being built or changed or modified by an AI agent. But you can also just lean back and let the AI do its work. Come back later, look at it, and just tell the AI what to do next or what to change. Now, let's go back to the problem of multiple type inheritance. As a developer, you might know that from your education, if you have a data model where you want to express that one data type inherits properties or attributes from two different types. And these types happen to also inherit from one parent type or super type. Then you typically get this diamond problem, which is also illustrated here. That means that there's a clash, there's a conflict between the properties which are inherited through both of the intermediate classes. And that's a big problem, because typically you cannot do that. And some programming languages just didn't implement this kind of inheritance. So, for example, the most popular programming language, Java, just didn't up to this day implement multiple type inheritance. But for us, it was always a big wish, and also our customers from our customers to use it. So we implemented that based on traits. Traits is a concept which is known from other programming languages like Scala, Rust, or Kotlin, and it's just avoids to express this multiple type inheritance in Java code. And yeah, if you want to learn more about that, just go to GitHub. Our source code is online. It's in the latest main branch. You can see how we did it. And typically you have to do conflict resolution. We chose a very simple pattern to just the type declaration or type definition, which comes last, just overrides any conflicting existing type specification. So that's a very, very nice feature, and that saves a lot of time when developing and a lot of headache. Going back to the building AI or using AI to build software applications. I think that's the most interesting and most exciting new feature in Structr. I will now switch to the live demo, and we try to build a simple project management application, because I think it's a domain that most of you are familiar with. We are using natural language to model or to create the schema. We can follow the progress live, as we can just log into the administration user interface. We can let the AI create some example data, and if we have time, we can also try to build front end. It's difficult to squeeze the full process of building a fully fledged application into a very short demo, but I'll give my very best to show you how that works. But in principle, everyone can do it like I did. Just download Structr, install the MCP server. It's not released yet, but with release 6, we will also release the MCP server. Yeah, as I said, we could the AI let build a user interface as well. Maybe we can do it if the AI is fast enough today. All right, let's switch to the live demo. This is the Structr system. I will just log in as the admin user. You can see everything is empty and clear. So we're starting on the green field, and all I have to do is to go to Claude and ask. Claude is the AI or LLM of Anthropic, and we just ask it to connect to the local Structr instance. Yeah, okay. So you see, it just worked before the talk, but we'll see. We'll see if we can do it. I will just restart it. That mostly helps. Please connect to the local Structr system at localhost port 8082. So this is typically where we start with. Okay, now it works. Okay, please create a simple project management schema, or please create the schema for a simple project management app with 3 basic data types. Of course, I could be more specific. It depends on your use case. If you know exactly what you want to do, you can just, of course, tell the AI what you want to do, and it will do it exactly like you want it, or mostly exactly. So the more specific you are, the better results you get, of course. Now you can see in the background here, the schema has been recompiled because any change to the schema automatically also changes also changes the backend, and once you have these data types, you could start right away adding data to it. But we will just wait for Claude to finish the work, because typically Claude will also connect the data types. I could do it manually by saying, okay, project is connected to a task. Define a relationship type, and this is exactly what you would do in Neo4j. The difference is, or the different concept is that in Neo4j you are creating instances of a data type. In Neo4j, it's not exactly a type with inheritance. It's more like it's kind of a trait, you could say. So traits really are matching the Neo4j data model much better, because you can match a trait to a label. But in Neo4j, it's more or less creating groups of nodes connected by relationships of certain types that share common properties. So let's see if it was able. No, it doesn't. It didn't have. It's creating properties here. So property are created, description, and name. And let's see what it did with the task description, priority, status, title. That's nice. Okay. So I hope that it also connects the data. It's creating some. Typically, you have to tell it to not do everything in the first step and to go iteratively from requirement to requirement. But I mean, it's just a demo, and I'm always curious what it does this time, because of course, that's in the nature of AI. Unless you don't specify exactly what you want to achieve or want the AI to do, it comes up with ideas, and it's sometimes it's just differs. The results differ. So it's better than vibe coding, because everything the AI does just changes a graph. It just changes data in Neo4j, and Structr sits on top of it and interprets the data and creates software components that work together very well. And so now it's ready. Okay, now you can see the connections. Let's see what it has done. Project has tasks. Okay, that's nice. Also, user assigned to tasks. A user can own a project. We can see we have multiple possible project owners. That's great. So one thing I typically do as a developer, I rename these linked properties that just connect the data. So for example, a project just has tasks and, sorry, in this direction. So this is the project side and this is the task side. So this way, addressing the properties is much easier. Now, the system is empty, so we don't have any projects and tasks, but we just let the AI create some example data. Create some example data for projects and tasks, not user, because user is typically something we would add through the security system here, because they have special properties like username, password, email address, and so on. You can connect it, of course, to your own classes, but we won't mix it for now. All right, let's see what it does at the moment. Sorry, I'm having a little cold at the moment. Okay, now it has some issues with WebSocket connection. That's sometimes the case. Let's see in the data section. Okay, we have one project. It's already connected to a user, but it's the admin user. Okay, so we have 5 minutes left. I think you get the idea. So the AI system, the LLM, is talking through the MCP server to Structr via the various APIs Structr provides. There's a RESTful API, a WebSocket API. You can also up and download binary data. That's also a possibility here in this file system. Just to show you, you could create folders and files. But maybe let's do one attempt to create a nice looking web page, so you also get this idea. I will just stop it here and let's see. Create a modern web page for a project list, and using Tailwind 4. That's a nice Tailwind CSS4. It's a nice component library. Import it into Structr. Okay. Let's see. So what it typically does, it creates HTML code. By specifying the component library Tailwind I'm using, we have typically a nice looking user interface already, and we don't have to do all the styling by hand. That's very, very handy. Structr has an import. No, it's not working, so it's not that as reliable as I wish, but let me try to, it tries to reconnect again. If it doesn't work, let's start again the AI tool. And as Claude can remember prior sessions, we can just redo the last command. We can just let it look up the last command, and hopefully it remembers and tries again. Okay, so I have only 2 or 3 minutes left. Okay, it didn't. Okay, create a Tailwind 4 page and import it. So it's probably a good idea to stop the demo here. So it's a little bit difficult to show it all, squeeze it all in a short demo. I hope I could show you how that works in principle, what Structr is about, how it adds to the Neo4j ecosystem. And yeah, let's maybe go back to the session and see if we have any questions. Okay, I see some questions. Okay. No questions, but just messages. All right. So if you don't have any further questions, maybe just wait for the AI to import it. But I doubt that it works. It's kind of slow at the moment. I don't know what it is. So typically, we go back to the presentation once more. You can see that in this screenshot, that's typically what it comes up. It's a kind of standard project management page, and then you can start wiring up, and you can also use the AI, but it's you have to know what you want to do, and our task as developers of Structr is to make it even more accessible to non-developers. That's our goal. So we are combining AI tools, the power of graph databases and a graph platform like Neo4j, plus the low-code capabilities Structr already has, and bringing it further into that direction. I think low-code development and AI are a perfect combination. All right, I think that's it for now. Sorry that the demo didn't work as well as I wish, but there's a question. When is 6.0 coming out? It's this month.
All right, thanks so much, Axel. If there aren't any other questions, we can wrap this session up and everyone can head on to the next one. And